Yep, there we go. Okay, welcome everyone to our last Brisbane Azure User Group meeting of the year. So a bit of a light crowd tonight, but it's good we see a lot of familiar faces here and a couple of new ones as well. So thank you. Welcome, group. Hope we see you more often. We meet generally the second Wednesday evening of every month. So sometimes we have to shift it for those silly things like state of origin kind of stuff. As people who come regularly know, what we usually do, we start every meeting with a little bit of a news roundup, just about, with the things that have happened lately in Azure, because the cloud moves fast and there's always tons of announcements. I don't claim to do them all, but I try to highlight the ones that seem to be big. And if I miss something, Todd will always kick in and tell us, or somebody that there's something I missed. So with that, we'll do the. Gotta get to focus on that, I think. There we are. Yep, so we'll hit the news. First, it doesn't seem to work very well. Okay. Manually. That's odd. Okay, first is a shout out to our sponsors. So obviously Microsoft giving us the venue here, which is great, and also the host for the evening, who also happens to be the speaker tonight, but that isn't always the case. So so we certainly appreciate Microsoft's contribution there. And Codify gives us the funding. They give us a monthly stipend, which pays for things like the pizza and the beer that you just enjoyed, our meetup group subscription, our Azure subscription, and all the incidentals like that. So big shout out for them. It's funny that this doesn't want to work now, whereas it did before. Here we go. Okay. So getting involved. This is, of course, a community group. So, and you are that community, and we would love to hear from you about what you'd like to see. But also, we would love you to come up and share with the group as well. So almost all the speakers that you see here are people that are just in the community like you and have kind of stepped up to volunteer their time to present. It doesn't have to be super polished. You don't even have to do a whole presentation for the whole evening. You can do a short one if you want, like 10 minutes, just to share something maybe that you've done that's interesting at your work, or a problem that you recently solved. We can always fit in things like that. So as you can see, this year we've had quite a full year of a lot of speakers, a lot of really interesting topics. And I do have someone lined up for January, but we've got plenty of open spaces for February next year. It's very slow. Okay, job opportunities. So if you're looking for a new adventure, Deloitte is always happy to hear from you, especially if you have any of the skills on those slides. And you'll notice that not all of them are Microsoft necessarily. So we have a great integration capability in Deloitte, as well as a lot of other technological stuff. So if you're really passionate about any of that stuff, by all means, reach out to me. Scan that QR code if you want. We'd love to hear from you. We have some very challenging clients. We tend to get the kind of we solve the wicked problems that nobody else really wants to deal with. So with that, we'll jump right into the updates. Now, these first few slides are going to be talking a lot about Gartner's Magic Quadrant, which of course is that upper right-hand quadrant in these. These charts always mean, if you haven't seen these before, the charts mean the vertical is the ability to execute. So the higher up on that, the better. And then the horizontal is the completeness of vision. So when you get into that top right square, that's the sweet spot. And Microsoft has landed there for cloud AI developer services. So what this is that basically Microsoft's created an SDK to kind of help people who are not data scientists be able to leverage the AI and the machine learning capabilities of Azure to help you develop against that, so that you can harness that power. And we actually landed again furthest in the chart. If you see, we're the furthest right of anyone in terms of completeness of vision, which is a really great accomplishment for Microsoft, and pretty far up there too as ability to execute. Obviously, we're only beat by Amazon Web Services in that. And I will, by the way, share these slides I'll post a link on the Meetup site so you can download these and access all the URLs and get the full story on these. The next one we landed in Magic Quadrant for was, again, for the 9th year in a row, infrastructure and cloud services. So we're doing really, really well there. And first time, again, we placed furthest in terms of the completeness of vision, which is really, really good. And then in terms of full cycle API, lifecycle API management, we learned for the 3rd consecutive year, we landed again in the Magic Quadrant to that. So I just made it in for that as well. And there's a lot of new things that have happened in API management. If you haven't used it, if you don't know about it, we've got support for new API types. For example, you can now publish existing WebSocket and GraphQL backends and APIs. There's also support for hybrid and multi-cloud API management. So if you want to access APIs, not just in Azure, but on-prem or in other clouds, or SaaS services or whatever that you want, you can basically expose them from anywhere in API management and get all that goodness that comes with that product. There's also been security enhancements as well, and a geographic expansion of where it's available. So they've added 4 more regions to Europe and China, again, making available across 58 Azure regions right now for API management. And the last Magic Quadrant one I'm going to talk about is in the data integration tools that we have there. So we've landed again in the Magic Quadrant. And some of the offerings that we'd be talking about there are Azure Data Factory, Power Query, and Azure Synapse or Synapse. I don't know how you pronounce that. I've heard it's pronounced both ways. So Synapse is a phenomenal analytical tool that you can use. Okay. In terms of preview, anybody here do any kind of space development? No?
Yeah, all the time, of course.
It means rearranging furniture.
Right. Well, this is an SDK to help the space-oriented developers, as opposed to spaced-out developers. And basically, it provides a set of templates, samples, and documentation just to help make it easy to get up and running as a space developer. So it includes template applications for common workload patterns, like, for example, Earth observation image processing. That would be one. There's also a virtual test harness that allows you to develop. So basically, you deploy this code as a container on your whatever it is that you're launching in space, but then you can control it from a management layer, and your virtual test harness allows you to test against that instance. So next in preview is also Azure Storage Mover, which is another choice that you can do for migrating files. So this is going to expand as it goes along. But right now, what they're enabled to do is to share files from an NFS share on your on-prem up to blob storage account. And it's quite performant because it's not only using the REST API capability of your blob storage directly, but it has pure separation of the management of those flows and actually sending a file. So the files go directly to the storage, and it's quite efficient. Cool. All right, let me just. Okay. Also, we got some new capabilities in the Azure Firewall, some which are in GA and some which are in preview. So we've got some new GA regions in Qatar, China East and China North. And then we've got now IDPS, private IP ranges, now generally available. So if you want to know what IDPS means, it's intrusion detection and prevention system. And by default, only ranges that are have internet assigned authority addresses are usually considered. But now you can actually add private IP addresses in there as well. So you can help protect those. There's a few other things too, like you can do a single-click upgrade or downgrade on your tier level for Azure Firewall. There's some enhanced threat intelligence, and also key vault now can be exposed with zero internet exposure on your key vault stuff. So helpful. Okay.
It's actually crazy that zero internet exposure with the keyboard has taken so long. Like
Yeah.
keyboard.
Yes, I know.
Yeah.
Absolutely. And there's some, the last one is some Azure cost management updates as well. So now you can, in preview, you can have tag inheritance. You can inherit the tags from your subscription or your resource group. And you can see in this window here that you can kind of choose how that's done, whether you, if you wind up with a collision with a tag with the same name, you can either keep the one that's in your resource or you can override it with the one from the subscription. You can also now compare your costs from the previous period to the current one. I'm surprised you didn't have that before. That's actually a really handy thing. Even your power bills, you know, all your other bills usually allow you to do that. So, and also there's some new cost recommendations for virtual scale sets. So, you know, it can tell you, give you hints like, you know, oh, you can reduce the number of machines here and save money, or, you know, do that kind of analysis. And there's some improvements to cost management labs as well. Okay, did I miss anything? There's no events coming up being the end of the year, although Ray seems to know that there's drinks on tomorrow night somewhere.
Just follow Ray.
Just follow Ray. In terms of resources, so we have a Slack team. How many here belong to the Slack team? Oh, only one or two. It's great. Get in. There's people post questions and people and experts actually come and answer them, which is amazing. So it's really good to get involved in that. I should probably put QR codes on these slides. We do have a YouTube channel. This recording will go up there along with all the other recordings that we make. So we tend to get a lot of hits on that. Yeah, and then we have some learning opportunities for you. So Microsoft gives you a lot of free online learning, including you know, hands-on labs and stuff like that you can do, which is really great way to learn Azure skills and get yourself set up for certifications. Of course, we got Pluralsight. Wayne works for Pluralsight, so and Obscurity. Yeah, we don't talk about them. There we go. Wayne and I are both Pluralsight authors. So. Okay, and I think for no further ado, we're going to get this slide. There we go. Tonight, we're going to introduce Todd, who, if you've been coming to this group for the last few years, you know that Todd's presentations are always incredibly entertaining and extravagant. I have to say, I'm a little disappointed, Todd, that there's not Christmas lights everywhere. Like,
hey, it was supposed to be a 15-minute.
But Todd is going to talk tonight about building hybrid apps in Azure 2022, and I'm sure there's nothing involves Commodore 64. Right?
Sadly, not.
There was
All right, let me stop sharing.
Just for your magic quadrants in Gartner, Azure Identity in Access Management is the top right corner with the two octas, Okta and Auth0 either side.
Oh,
nothing else really close.
Yeah.
Okay, there we go.
It's turn. Oh, do you have the
Clicker?
clicker?
Thank you.
Slide. Yeah.
Sorry, you guys got locked downstairs. I'm sorry about that. I couldn't see my messages when I was. Like somebody, how does Andy get in?
You know, man, that's how.
You've got to love security, don't you? Thinking.
I never actually thought that you get locked downstairs thing was a real thing. I actually thought that was just like a thing that he adds to the meetup. He's got all the every single invite. He's got like, make sure you get there before 6.
Yeah. Oh, yeah, no, because we can't cross
Yeah,
the building door. Yeah.
Yeah.
Well, there's the building door, there's the lifts, there's this door. It's a process. It's okay. I'll just have to do clicky. Right. Okay, thank you, Dan. So as Dan said, my name's Todd Whitehead. I think I've met most of you, but there are some new faces, which is awesome. So I'm a cloud solution architect for Microsoft, like 99% of the people at Microsoft. And my focus area is in application development. So I work with customers to build cool things in Azure. So this was originally going to be a 15-minute lightning talk, and then all of a sudden I was the only one. So now it's a lot longer. I hope it's interesting. It's certainly not as polished or dramatic as what I normally do, but I hope it's going to be interesting. So let's get cracking. Or maybe it's, hang on. Maybe Clicker does work. No, Clicker doesn't. Okay, that's all right. So this is going slow. Okay. So as I said, I work with lots and lots of customers building things in Azure, right? And this is the cloud native stuff. This is what normally, 9 times out of 10, this is what I'm talking to customers about, whether it's Kubernetes or serverless, Cosmos, and these things. These are kind of the cloud native parts of Azure that for building apps on. And as we've seen from Gartner, most of these things are up in the top right, and it's all super groovy. But what I'm finding, particularly the customers I'm working with at the moment, they might have very specific requirements. Whilst they might want to do this, they do face some challenges. There we go. So I don't know the name for it. I've called it hybrid apps. Maybe flexible apps is what I'm going for. So really, it's these kind of situations. They want to build apps. They want to build them cloud native. They're using those things, but they might need to run them on-prem and in a cloud, right? And that might be that they actually have them running in the cloud both at the same time. That might be because, the latency requirements or regulatory requirements, or it might be on a mining or a gas place somewhere that actually needs it running locally. But they also want to take advantage of the scale of the cloud. Or it might be, hey, we're going to run it in Azure, but we want to be able to pull it back on-prem at any time. And that might be a disaster. It might be any other reason, right? So they need that. They want that portability. Equally well, they might sometimes want to use PaaS. So, for example, they might use our SQL PaaS database or Event Hub or Service Bus or those kind of cloud scale things. But then sometimes they don't want to run those. They have a specific requirement for a workload. Oh, we want to use product X, or we need to be able to run on-prem. And we'll see some services can certainly run on-prem, not all of them. Service Bus is a great example. So how do they deal with that mixture of using PaaS and non-PaaS? Sometimes they need to actually stretch the app. So the app actually runs in both places or runs in one place and connects to services in the other. So how do they do that? And then the other one, which is becoming more and more common, is they want to do different deployments, even if it's in Azure. For example, there might be certain times a year where that app is really busy. And yes, you can scale things, but depending on the services you've chosen, there might be a minimum, even the scaled down version maybe is expensive. And they don't want to do that. So they want to actually have their app deployed, maybe when it's busy at Christmas, if they're in a retail store. If you're in, I always remember working with, a particular Queensland department that looks after education. I'm not saying which one, but the beginning of the year, there's certain apps that are super busy because people are applying for schools and rostering classes and things. And then the rest of the year, it's super quiet. So what do you do? So there's all sorts of different nuances, I guess, when people are building apps that gets interesting. And on the challenge with kind of thinking about those kind of things like these, it's great. We can do it in the cloud or we can do it on-prem, but those tend to be very different operating models, different tools, different ways of approaching things. So one common approach is, well, if we need to use, product X on-prem, then we'll just run it in a VM or a container in Azure. So they're not taking advantage of, the scale and cloud native services necessarily. So if you don't want to do that, how do you manage that? If you did want to support multiple services, then potentially there's some significant application development effort there. I mean, if I want to be able to swap out Azure Service Bus and drop in RabbitMQ. I need to write some code. I need to figure out how to do that. So that's definitely doable, but it is effort. And I guess the question becomes, is it valuable effort or not? And the last thing is, of course, how do you test in these different environments? If they're using different stacks and different technologies, if you change your app, do you need to think about how you're going to test it? So what I want to cover through tonight, as I said, this isn't super polished, so people start yelling at me and going too long, is just very, very briefly kind of look at how did we get here? What's the evolution of it? And then kind of, I guess, start at the bottom and build our way up. You know, what does Azure have that can help us, you know, help to solve that infrastructure element? How do we then look at layering on Azure platform services on top? And unfortunately, Damien's not here because I was going to make lots of Dapper jokes at his expense because we have a running argument about the usefulness of Dapper. But I'm going to take a look at Dapper and see how, you know, maybe it can help with this problem. So I guess tonight's talk, because it does cover a lot of things, it's not going to go into super great depth in any one topic, but it's sort of a bit of a view of the landscape. So hopefully there's something relevant to everyone. Please feel free to yell out questions and abuse as you see fit. So I kind of went back through my archive of sessions I've done here, and this was actually one of my first ones, if not the first one, where we had, just trying to think, Ray, you were probably here at that time. So we had this was what, 2000 and, I want to say 15, maybe 16? Yeah, so we had, just to give you an idea, we had someone who was flying around in a flight simulator, and we'd written some software that was running on his PC, collecting all the telemetry from that aircraft, and then we were sending it up to Azure to do some processing. Because this is what hybrid looked like back then, right? So we're using all these really super good Azure services, Event Hub, Stream Analytics, SQL, and whatever, and we were running it from on-prem. So the actual application, if you like, was running on-prem. But it worked. It was great, but there was no kind of concept of, you know, the cloud part didn't really know about this part. You know, there was no concept of identity for an app calling from outside of Azure. You know, there was no management of that. There was just a RESTful endpoint we could hit to put some messages into Event Hub. But that's kind of where things were in. It was 2015. Fast forward a couple of years, and those who remember the Christmas lights, the Internet of Stranger Things, where you see how much the world had moved on in a short space of time. So again, this was a kind of an application in the same space. It's kind of that Internet of Things. This was using voice control and telemetry and all sorts of things. But the difference now was there was something in Azure that actually understood what the things calling it were. So there was the concept of identity for these different apps and different devices that sat out there. But importantly too, those services we saw before, we could actually now containerize them and deploy them down to the edge. And this was really kind of, to my knowledge, the first of these sort of services where you could do that. Not only things we'd seen before, like Stream Analytics, Azure Functions, but also the cognitive services. So Dan mentioned in his update about those developer-focused AI services. You know, they were some of the first ones where you could actually containerize those, tell Azure to deploy them, and it would manage that deployment for you down to the edge. And that was great. That was a big leap. The gap still was here, though. This actual whole blue box here, this IoT Edge, you had to manage it. Right? Whether that was a Raspberry Pi or a server or whatever it happened to be, Azure didn't really help you manage that side of thing. It looked after what was in the box, but you were responsible for patching the hosting, making sure it's available, doing all those kind of good things. So that's kind of the next step along in that journey, which sort of brings us up to where we've been until very recent. So, you know, people who are building apps in Azure, they're very familiar with these sort of services, and the world was very simple. We didn't worry about that IaaS stuff. Who cares? We kind of had our PaaS services like App Service, got the new container apps. And then, of course, Kubernetes came along, and we know the answer to every question is Kubernetes. But then because of that, things started to get a little interesting and weird. So one of the first steps people may have noticed is, well, go back. You started to be able to deploy things like Azure Logic Apps, Azure Functions, things like that on top of App Service. So that's kind of started to happen. And then it started to get even weirder where you could now start to run all of those directly in Kubernetes. And again, as containers. And that's kind of changed the landscape quite a bit. And that was great. We could still do that, but we still had that same problem of how do you actually manage that infrastructure that's going to host these services? And that's where Azure Arc comes in. Has everyone heard of Azure Arc?
I feel like there should be like a.
Oh. So Azure Arc is a way of basically extending the control plane of Azure to cover things that are running outside of Azure, right? So if we think of when we want to deploy a VM or a database in Azure, we use our CI/CD, we use our whatever tool we want, but ultimately it goes through an API through the Azure Resource Manager. Azure Arc allows us to do that to create and manage infrastructure that might sit on-prem, it might sit in another cloud provider. But once it's there, then we can start to manage them and treat them just like they were Azure resources. And there's two kind of different scenarios here. So the base one there is actually managing of the infrastructure, which is kind of what we're focusing on first. But then also, once we've got that, we can then deploy Arc-enabled services on top of it. So that's everything from like the app service, the logic apps we spoke about, through to things like SQL managed instance we can run on-prem, deployed through Azure Arc and managed by Azure Arc. So what that allows us to do, it's kind of the first step, I guess, in thinking about how we might build hybrid/flexible apps is, well, we can actually manage our infrastructure the same way. So hopefully that simplifies the management, reduces the friction to thinking about that. And we can also start to pull those same Azure services down on-prem that we might want to use, regardless of kind of what infrastructure we want to use, whether that's Google Cloud, AWS, or on-prem, VMware, whatever you want to do. Or devices like the Azure Stack HCI to run hyperconverged infrastructure. So starting to get that consistency. So that's where we're going to drill into first, looking at the infrastructure. So if you go to the Microsoft Docs and you look at all this stuff, it talks about all the doing this on-prem stuff, and then it takes you through step-by-step tutorial, and you provision them all in Azure on VMs, which is, to me, is completely cheating, because none of the problems you hit when you do it on real infrastructure do you encounter, right? It's functionally equivalent, I get that, but certainly you don't hit the rough edges. So this is why I built the Hybrid Azure Lab, the HAL. And I did think long and hard. Originally, you'll often see these things done on like Raspberry Pi clusters and things like that, which I had. There's a couple of challenges there. One is that a lot of services still require or don't run on ARM processors. That's changing the way the world's working, but at the moment that's still there. There's limitations. And the other thing was that at the moment, try and buy a Raspberry Pi. They're unobtainium. Whereas these little things, you can go onto Facebook Marketplace, whatever. You can pick these up for about $100 to $150, depending on the spec. And these are Gen 3 i5s, 8 gig, 4 gigs, even up to 16 gigs of RAM, big hard drives and things. So they're a decent size to actually deploy some workloads to. They have networking, and they actually stack really well. You don't think about that, I guess, at the start, but when you try and put lots of Raspberry Pis close together, the new ones, all the heat goes that way. These things have nice vents on the front, the hands at the back, and go through it. So that's what HAL's built with. We've got 4 of those up here, different specs. And the fact they look like HAL was just kind of a bonus, They do look exactly like that. And I'm assuming everyone old enough to see 2001 knows why HAL is HAL. Add one letter to each. Add one letter to each letter. IBM. Who sponsored them? Oh. And these are IBM. These are Lenovo/IBM machines. Like an onion, there's layers. So what we're going to do, the first step is, so we've basically got these set up. We've got 4 in the cluster. They're running Ubuntu 22.04. And we want to onboard them to Azure. So the first thing we need to do is we need a role or an identity that has permission to do that. And there is, assuming this thing has a laser pointer, there is actually a role, predefined role in Azure you can use called Azure Connected Machine Onboarding. It kind of tells you what it does. So there's certain permissions you need to give it. So by using this role, you can create an identity that only has those permissions. It can't do anything else. So at least permissions. So we want to create a service principal that'll have the permissions to do that. Run away, creates the identity for us. Super groovy. We've got an identity. Now, even though we're doing this on-prem, I wanted to think about this is how would you do this in real life? Hopefully, you're not going to log into every terminal and do things the same. Ray, why do you look at so I used Ansible. So Ansible is an automation platform. Really, really good at doing these kinds of things. It's free. It's super awesome. So basically, all you have to do is create a what we call an inventory file. So here's the IP addresses of these 4 hosts. I give it some identity, like the user that it needs to log in on these machines. I've got it set up with private keys, so I don't need to log in all the time, and it's super easy. And then once I've got that, I can run commands, and it can run them on all the machines I want. So here's just doing a simple ping, and you can see each machine comes back. Cool. So we've got our machines. And then you can go to, on the Microsoft Docs, it has a Ansible, what I call an Ansible playbook. So there's the 20 steps you need to undo, or you can run the book, which basically does exactly that. So basically, this is you give it some properties, which are what we got back from creating the identity, and subscription ID in Azure, basically where you want them to land. And then it's going to run through. And it's basically going to run through that. It's going to run through and fan out onto these 4 different servers and run the same thing. And, the basic steps. It's got to pull down. There's what's called a virtual machine agent. It's going to pull down. It's going to configure some things. It's going to do some magic. It's going to keep along. You can see it's doing it on all 4. And the great thing with this, it is idempotent, so you can just keep rerunning the script. And if one of the machines, so if I added a new machine, I could run the script again, and it would just add the new one. It would check that the other ones already have it. And as I said, this playbook's on the you can download it from Microsoft Docs. It skips like 20 pages of instructions that are very, very long and boring. Long and boring. Okay. So you can see the task there. It's basically just downloading an agent, connecting up to Windows. And the nice thing is this playbook has the correct commands for Windows, Linux, and Raspberry Pi even, because there's some subtleties. So you just run the same script, it figures it out and runs the right thing. Because you might do this in a mixed sort of environment. So there you go. At the end, we get the little recap to say, okay, made 3 changes, nothing skipped, so it all looks super good. So now, in theory, all our machines there. So if we jump over, if we jump into the Azure portal, we'll now see those 4 servers listed in Azure under the resource group I gave it. So we've now got a projection into Azure, so we can start to do Azure-y things with them. This is really flaky. I don't know why the slide. So if I drill into one of those machines, you can see what the agent version is. We can see the operating system, the computer name, and all those kind of things. But I can start to do things. I can go and configure update policies. I can apply Azure policies. I can go and tag virtual machines. I can do all those kind of things I can do on a normal one. For example, I might go and configure it to use the Azure Monitor agent. So I can go in and do this, machine by machine. But I would probably go in, instead of doing that, I would define a policy that would go and push this machine, the monitoring, directly onto it. And then as soon as I've done that, even though this is in Azure, all the data from my virtual machines are up there running. I can monitor, I can do alerts, I can do all that kind of good things. So step one, we're getting there, but it's I guess it's helping to break down that barriers of talking one thing in the cloud and one thing on-prem. And although this is super detailed, just to explain what's kind of happened up in Azure, so you can see down here the Azure Arc server resource provider, because everything in Azure has a resource provider. So it has a corresponding agent, and when we ran that script, it installed that on each of the agents, connected them up and did the thing, and that's how they got into Azure. And basically, we're going to see later on, we're going to see the exact same model for Kubernetes, or if we're using any of the data services that can be Arc enabled, things like SQL Server, can equally be, and there's an equivalent one of those. Oh, there we go, it's working. So now we've got some VMs, we've got them projected into Azure. Now, because we know the answer to everything's Kubernetes, we're going to put some Kubernetes on there. We have a few choices. There's lots of, like everything in Kubernetes, the worst thing is how much choice you have. In this case, I picked K3S. I've used it before, which is a plus, but it's very, very lightweight. So it runs as just a single process. It's super easy to use, so I use that. You can obviously use absolutely anything you wanted to. Okay. And I've pulled out Ansible again because to install it, there are some steps. Actually, I didn't put a diagram in there. This is where one of the things of if you do this in Azure virtual machines, you're cheating. Because Kubernetes was born in the cloud. So it assumes all the good cloud stuff is there. You need a load balancer? Load balancer. Do that on-prem. There's no load balancer, right? Kubernetes doesn't have a built-in abstraction, so you have to use what you have on-prem. That might be, you might have 5 Altos, what? Or there is software versions you can run, but you've got to go and get those and figure those and learn how to do those. So luckily, again, there are open source products to do that, and there's a publicly available Ansible playbooks to go and install everything for you, so I don't even have to think about it. So similar again, the only thing you'll notice here is that in my inventory file, they actually have some different groupings, if you like, for VMs. So what I've said is, because again, I need to think about, I'm on-prem now, I need to think about how am I going to make the control plane in Kubernetes highly available. I can't just run that on one node, because that node goes, we're done. So one of the nice things with K3S, the nodes can be both control plane and host workloads as well by default. So here, even though I've only got 3 master nodes or control nodes, I've only got 1 workload nodes, all 4 nodes will actually get workloads, so that's kind of cool. But the reason we need this now is that Ansible playbook is going to do slightly different things on the master node. It's going to set up the highly available configuration files. All the good things it does. Yeah, the clicker's working. Yes. Okay, it's going to run off. And again, it's a super long thing. It's going to install load balancers. It's going to do all that kind of good thing for us.
So what was that load lab about? It's traffic?
No, so this one actually uses 2 different, because there's actually 2, you need to think about 2 types of load balance. You need the load balancing to the control plane, and then you need the load balancing for your inbound traffic. So this one actually uses kubevip for the control plane traffic and metal LB for the info traffic. You could use traffic, you could use a whole bunch. But again, it's the complexity. If you just do it if you just spin up AKS, you never see any of this because AKS does this for you. That's why AKS is awesome. And there's a method to my madness. Going. Manually click play. But there we go. So we run that Ansible playbook, and then I can do a kube control get nodes, and we can see we've got 4 nodes, and I got 3 of these from one person, and another one arrived 2 weeks later, which you can tell because I completely forgot what my naming convention was in that 2 weeks. But once that thing is run, you can see locally we can access that Kubernetes control plane, and we can see all the good thing is there. Metal LB is there to do our load balancing, and that's all kind of good stuff. Because if you're doing it by hand, or yourself, this is kind of the stuff you need to do. Okay, and finally, after I've done all that, I can actually just do a bit of an example deployment, just push a web container there to make sure it works. And hopefully, if I then do kube control like that, it should show me that it got an IP and all that kind of good thing. So we're 100% operating locally. Yes, Azure at the moment is only managing the infrastructure, but this is kind of just getting things set. So we're ready to go to the next step. And then we've got Hello World. Super. So again, as I said, right, all we've, so for the next step, what we're going to do is now actually Arc enable Kubernetes itself. Because at the moment, Azure knows about the VMs, but Azure doesn't know about the Kubernetes that's running on those VMs. So it's actually going to use this another agent, very cleverly called Arc enabled Kubernetes services, to do that. So again, you can do that yourself, or you could just go and, in this case, so in this case, we actually need, I'm going to do this one on the CLI just to show something a bit different. You do need to install some additional extensions into the Azure CLI to make this work. Not particularly complicated. Okay. And now all we need to do, there's a specific command just to help us connect this cluster, which we can already connect to. We just run this command, connected K8S in one word. I'm sure that did pass some kind of design review. Give it a name. So we're telling Azure, hey, this is the name we want you to call it, and I want you to put it in this resource group. Obviously, those resources are still on-prem, but the metadata and everything else from an Azure point of view, we'll do that. And that'll download a Helm chart, do all its Kubernetes magic, install the agents.
So the agents are run within the cluster that you have deployed.
Correct. For the Kubernetes.
For the Kubernetes.
Yeah. So once we do that, it spits out a whole lot of things. And if you've ever done anything on provision anything in Azure, this looks exactly like what you would get there, all the sort of metadata about it. And if I go and have a look at what's now running on my cluster, you'll see it's created a new namespace called Azure Arc. And if we go and have a look at that, there's a whole bunch of stuff in there to do the things it needs to do. From our point of view, though, all we need to know is that if we go back to Azure, we'll now see a new Kubernetes cluster, the version, the resource group. And this is the name we specified. And just like before, just like we create an AKS cluster, we can drill in and start doing things, installing extensions, doing the same sorts of things we would do in Azure. We can drill in and see the namespaces. So all those things that previously we wouldn't be able to see, because it's now connected to Azure, we can go in and have a look at them just like we would in AKS. So all the plumbing into Kubernetes is there. We can store it. We can manage at the VM level, and now we can manage at the Kubernetes level and install extensions, which will come in very handy in a second. So that's really all infrastructure. Kubernetes is still infrastructure at this point to us. Now we can actually deploy some Azure services, some platform services. So there's a number of ways to do this. There is the Helm charts and different things, but because it is now registered in Azure, we can go in and there's if you've used AKS, there's this concept of extensions as a way to install things into Kubernetes without worrying about all the complexity. So we can go in there and we can tell it what we want to install. So if we were going to do lots of data workloads, we can install data controller. If we're going to use Key Vault, do that. But in our API management gateway, VMs, Event Grid. But in our case, what I want to focus on is app services. I'm saying we want to go and install app services in our cluster, please. And the way this works is when you're deploying a workload in Azure, one of the things you have to tell it is which data center you want it in. Do you want it in Sydney? Do you want it in Melbourne? Do you wherever? We go in Azure, we create a new custom location, which is called Todd's black metal thing called How Cluster. So we create local names that represent whatever that is. That might be, it might be a particular environment, it might be a data center, or it's whatever you want it to be. But once we've got that, I can go and deploy something. So here I'm going to deploy a new app service. I'm going to give it the resource group, the name, just like we would in Azure. The only difference is I'm going to tell it to, oh, I had an ID set for that. So basically go and install it on here, but I'm using the exact same Azure command to create an app service that I would somewhere else. And when I do that, just like I would as if I'd done in Azure, I have an app service, which is now running on top of the Kubernetes, which is now running on top of the VMs. But from the point of view of an app developer or someone managing it, you just manage it. It's just app services. You just manage it however you want. You'll see down here, this is kind of, there is an, as well as going through the app services, there actually is an Azure Arc part of the section you can drill into, and that makes it really easy to get to the different types of things that you would do. And you can drill in and you can see one of the things I'm pretty sure it was on here. You can see you've got a URL, so you can actually hit this from outside my cluster and it will route through and do all those kind of good things. No, we had that there. But this is Azure.
Sorry, Todd, one slide back. Did I see System Center Virtual Machine Manager in the preview?
You did. You did. Funnily enough, it's almost like a page. So we kind of got there. We kind of deployed a lot of stuff, but there's a lot of steps in there. Just, if we think back to our goal of, I just want to build apps, I don't want to manage infrastructure. But, managing VMs is hard. It's work. Managing Kubernetes, particularly on-prem yourself, is hard. There's a lot of things to do. It's not as easy as just going to, create an AKS cluster in Azure. Now you can, because AKS as a service can now run on your own VM hardware. At the moment, it's GA if you're using Azure Stack HCI or just Windows Server, I think 2019 and above. I've done it on 2022, which is where the Commodore 64 was coming in, because that was going to be a Windows Server 2022. Anyway, so those are GA. But at the moment, it's GA, but you provision it through either PowerShell or through the Windows, or WAC. Windows Admin Center, is that right? Yeah, Windows Admin Center. That's what's GA. There's some interesting stuff coming in preview, Azure Stack Edge, Azure Stack Hub, and Azure Windows IoT, which I'll talk to at the moment. But what's also in preview, and because I didn't get time to get this thing, I've stolen someone else's video, which is perfectly acceptable. Get to it. So let's have. Keep playing. Not cut. Oh, I didn't cut and paste the video. I'm so disappointed he's not here. Okay. For some reason, it's copied that as a picture, not a video. But basically, now in preview is if you've connected an Azure Stack. Oh, now it's better. It's one of those days. So everything we've just done there after the VMs, we can skip. We don't need to manage Kubernetes anymore if we don't want to. We can come in and say, okay, I want to create an AKS hybrid cluster. So what that's going to do, it's going to talk to our Azure Stack, Azure Arc enabled infrastructure we've got on-prem, and allow you to deploy it there, and it'll deploy AKS. It'll take care of ingress. It'll take care of all the load balancers, and you don't need to touch it. It's AKS.
All right, so you did the hard way previously, did you?
Because you wouldn't have, you look at this and go, who cares? You kind of now get what, oh yeah, why did you give me that option?
Yeah.
Right?
Just do point and click.
Yeah. Well, you wouldn't obviously, you'd do infrastructure, but yes. So this is in preview, but the actual product itself is GA if you deploy it via the Windows Admin Center. Just going great.
So basically, it would be the Azure load balancer, but it would communicate with that infrastructure.
No, because it's still running on-prem. Azure Load Balancer doesn't run on-prem. So it's actually using, just like I did, I picked Metal, or the playbook I used picked Metal LD and KubeVip. don't quote me on this. I believe it uses kubevip and Envoy, I think. But it's again, it's using because it needs stuff that can run inside the cluster. It can't rely on Azure Load Balancer. But the point is, from your point of view, it's a service you just use. You don't need to look under the hood. Azure manages it for you.
Yes.
If you want to do it with
Also,
your own.
So when it's a hybrid cluster, how is it exposed to Azure?
Oh, so depending, well, it doesn't. So at I guess, two different levels, right? At the control plane level, there's control plane access that's needed so it can manage the clusters. There's operators and things inside the cluster. But from a workload traffic point of view, you don't even need to. You might not want to expose it to the outside. But it does.
But if you
want to, so how?
I might have this wrong, but I think that, and you might be able to correct me if I get this wrong, but I believe the Azure Machine Learning is an outbound connection to communicate.
Yeah,
correct.
Yeah,
that's
what
what
it
it is.
was actually.
Yeah.
The inbound part is the I think
That's for the management. That's what I was saying about that's management traffic. Yeah, management plane.
the inbound part, I believe, is done through a reverse proxy in the connected machine agent as well.
Right.
So
But not, for example, if you're doing local traffic on-prem, that's not going to be going
No,
through the.
Oh, well, certainly.
Yeah.
Well, you certainly deploy infrastructure to install services on them.
the only reason I think that is the case is because you can now do like a reverse proxy SSH through the Azure connected machine.
Yes.
And so
Yeah. So I guess the point was all that hard stuff. If you don't want to, you don't have to do it.
hell
Right. If all you wanted to do was deploy it so you could deploy Azure services, that's a much easier way to do it. That AKS, as you saw, is coming to a lot more platforms, and it's also coming to other hypervisor platforms, which shall remain nameless, very relatively soon. The other interesting one, remember I kind of started with when we had the Azure IoT thing, because Azure, the IoT has had an interesting journey with Kubernetes, because the actual IoT Edge part kind of existed before Kubernetes was a thing, before it was, it won the orchestration wars. So IoT Edge uses its own model for deploying containers and managing and whole things, right? So if anyone remembers, like about 4 years ago, there was a preview for it running on Kubernetes, and the idea was that basically there'd be an abstraction layer so that, yes, you could talk to IoT Edge, but it would just, under the hood, talk to a corresponding Kubernetes construct. Unfortunately, that was in preview for like 2 years and then was abandoned. One of the challenges with Kubernetes, it moves really fast. And when you're talking about IoT workloads, they're kind of things you can't have moving really fast. So it actually became a problem. So there's now a V2, which works much better. And I think I left out the diagram, but I'm sure Ray would appreciate it. IoT Edge, the whole stack, the container, the orchestration, now runs inside a tiny, tiny little VM, which runs inside a pod, which runs inside a Kubernetes pod, which runs on a host. It's like 6 levels of inception, but it works.
That's not a nano server disguise.
No. It's, what is it? What's that super lightweight?
Linux.
QEMU. There's too many products.
Yeah, QA.
Is that, yeah, so it runs on that. So it runs inside a, which, my brain instantly recoils against because of the overhead, but the overhead on some of those things is so tiny. It's really good. But there's also, you would have seen AKS. So now we're not talking about IoT Edge, but actual version of AKS is coming that'll run on light devices. So think edge devices. And this is based on K3S, which is the same one I've done here. So super lightweight, runs in one process. Yeah, this is not out. I'm desperately trying to get a hold of this. But
does that run on Windows IoT? Is that what that
it can run on, it's there, right? It can run on Windows IoT, 10, 11, Linux, whatever, but it's designed for edge compute workloads. So it can run multi-node, but you're not going to run this flavor on, big hardware. Wouldn't make sense.
and ARM with this one?
Yes. So yeah, the workload will, whether the workloads you're going to run on it. So, but
Yeah.
ARM's complicated. And Damien's not here, unfortunately. So, so great, we've got infrastructure, we've got platform services. So for example, we could now deploy, app service, we could deploy logic apps, we could deploy SQL MI into our cluster and use those services just like we would in Azure. So we could kind of think of that as our hybrid. And depending on the scenario, that may solve it, but it doesn't solve all of those use cases we spoke about. Because, for example, there's lots of services in Azure that don't run on. So again, I use the service bus as the classic example. Right? So, lots of cloud native architecture need messaging, need pub sub, need all these kind of things. So we've got some gaps there. And that's where, as I was thinking about this, sort of Dapper starts to fit in. And yes, Damien's completely unconvinced by the value of Dapper. So you'll see this, Damien, when you see this, you'll understand. So just very quickly, what is Dapper? Dapper is a open source project, and it stands for Distributed Application Runtime. So it's really helped design, it's focusing on developers, people who are building distributed apps, microservices, those kind of things. And it's designed to provide all the building blocks you need to build, right? So these are the common problems we need to do. Hey, we need a way to call from one service to the other, which sounds super easy, but there isn't a way in Kubernetes built in to do that in a managed way. All right, then you start needing, now we need an open mesh, and that adds a whole, we need a mesh sort of product, but we need some other things which add complexity and things like that. And then beyond that, there's these kind of really common things we need to do. Hey, we need to store state. Particularly if you're building microservices, you've got lots of services that have their own data stores, you end up with a lot of these things. So we need a really simple way to do this. We need to be able to publish and subscribe to messages. We need to be able to bind to resources and triggers. So if anyone's used things like in Azure Functions, you have the input and output bindings, those kind of things. Hey, run this function automatically when a message is on a queue or a blob arrives on a blob store, those kind of things. And a whole bunch of other stuff. Okay. What's neat about this is it runs on any code or framework, as long as it can do HTTPS or HTTP. It does come. There is an SDK you can use to help you make life even easier with all the languages you see listed here. But you don't need to use that at all. So you don't need to take a dependency on the thing. You can just call it as a RESTful API endpoint, and you can just use the bits that make sense to you. You don't need to take it. Just use bits and pieces. So it's not like if you've used Azure, I'm trying to say, Service Fabric or any of those kind of things. Those do kind of a similar thing, but you have to buy into the model, right? You buy into this whole structure, which then means it's very hard to move. And then it can run on any kind of infrastructure or cloud. So that's the intent. And the way it works technically, that's the thing. It uses a sidecar model. So basically, if we think about when you're deploying an app, or if you say it's a container, right alongside it gets deployed a sidecar, another little container, which is the Dapper container. And your app, think of your microservice, it always talks to that thing. So for example, if you wanted to invoke a method, you'd say, hey, Mr. Container, which is on this local address, go and call this, go and get me this bit of state. So it's a set of APIs that your app can use. Yeah, you can see there, we've got all those different types of building blocks, get me some secrets and do whatever. Oh. Okay. But the other nice thing about it is then once you've got that, your code isn't referenced. So your code isn't taking it, for example, if you're using Service Bus, you're not including the Service Bus SDK. Your code doesn't talk about Service Bus constructs at all. It's only talking to Dapper, say, hey, go and publish this message on this topic or with this thing and that. And then what you then do is you have a definition, an external definition that says, here's the component you're going to do that. That might be Redis, that might be an Amazon service, it might be Azure Service Bus. So when you want to change from one to the other, as we'll see in a sec, your code does not change. You just change the definition of that separate file to say where to go and get it from. So to make that a little bit real, go through some more demos. So everyone else seen it, there's a really good, a few years ago now, Microsoft published a book. It's free, grab it, called eShop on Containers. So it's like a normal e-commerce site, but it's kind of like a reference architecture, a best way of building a microservice application. I think 5 years ago, and that's a really good book. You can still go and read that, if particularly things like how do you do polyglot persistence, how do all your services store their own things, and then you've got to do queries, all that kind of stuff. So what they've done now, though, they've taken that exact reference model, but now built it on Dapper to show you the difference. And that's what we're going to have a look at. So just as a bit of an example, this is the eShop on containers. So this is the non-Dapper version. I've even lost my pointy light. Okay. I guess the important thing is, down this end, these are our actual microservices, and you can see some of them are talking to SQL, some of them are talking to Redis, and then they talk to each other via this event bus, this publish and subscribe bus. And in the reference example, they give you 2 implementations, one in RabbitMQ and one in Service Bus. So you can choose. So let's have a look. So the way the code works, we've got decoders, they have an interface defined, has all the methods you would need to publish to an event bus. And then there's an implementation for that interface that has to know specifically, okay, this is the RabbitMQ one. It implements that interface and it does all the RabbitMQ specific things. It takes dependencies on SDKs or libraries and does all those kind of things. So you need to maintain that. If you wanted to go to the Service Bus one, there's a whole separate set of code that implements it for Service Bus. So you need to design and maintain and manage all of that. So that definitely works. That's a good pattern. But again, for developers, they need to go and build all that. They need to understand how to work with Service Bus. They need to understand how to work with RabbitMQ and do all that kind of good stuff. When we look at the Dapperized version of the architecture, it's the same services, but it has built into it all the Dapper building blocks we're going to use. So specific, what do I keep pointing with the pointer? At the back here, we've got the same Service Bus, and I'll show you the difference in terms of the code, how little work you need to do. Let's jump and have a look. So this is what, compared to all the code we saw before, in a Dapper world, we have this component we call it eShop Hub Sub. So that's the name of the service, if you like. And then we tell it what backing store do we want to implement. In this case, it's RabbitMQ. And there's about 70 or 80 different products implemented you can go and choose from, or you can write your own. And the metadata itself will vary per service, but this just goes bundled up in your deployment file. And then in our actual code, we don't ever talk about, let's say RabbitMQ. If we want to subscribe to an event, for example, we just annotate our thing, tell it the name of that thing, whatever it is, and what event we want to subscribe to, and that's it. So our code doesn't need to change, doesn't need to know about that type of thing. So the first thing I did was, okay, I took that sample application, the Dapper version, and now I'm going to deploy it onto Howard here. So because this is Kubernetes, I need to create the containers and things I need, the backing services. So I'm going to use RabbitMQ. I need to create a container, do a deployment that's got RabbitMQ and those kind of things. So I've got a standard kind of Helm chart here, just defining all the different things I want. And then I deploy it, and then I get all these wonderful services I've got running. Redis, so we've got Redis here. There's this one. It was actually running SQL Server in a container. So that can obviously be a SQL Server separate, but in this case, it's running completely inside the cluster. And they've upgraded the app from those ones to Blazor, which again probably keeps Damien happy because it's all about the Blazor. Once I do that, it ships with some health checks and things, so I can actually go in and check, yes, all the services have been provisioned. So you can see here I'm hitting an internal endpoint, so it's only on-prem. I haven't deployed this to Azure yet. I can go and see that, yes, the actual, apart from my containers, they've all got this Dapper sidecar, Dapper's healthy. It's managing all the connections and doing all those kind of things. Then I can go to my super exciting e-commerce. So that's how we would do it on-prem. So let's think about now I don't want to run it on-prem anymore. I want to run it in Azure. So if I was just going to deploy this to say AKS, in Azure, I could literally take that same deployment file and deploy it because it would run up there and deploy the SQL containers. But if instead of doing that, I wanted to use service bus and things like that, I would just change the config. But just to show, I guess, rather than do Kubernetes to Kubernetes, what I want to do is let's actually go and deploy it to Azure Container Apps instead. Right? So again, this comes back to the idea that it's not just that I want to run it on-prem or in Azure. I might want to run in Azure in different services depending on reasons. Okay, so Azure Container Apps, for those that don't know, it's powered underneath by Kubernetes. You don't see it, you can't touch it, you can't interact with it using the Kubernetes control plane. Think of it more like app service, but it's designed specifically for hosting microservices, but it has Dapper built in, which is really nice. I could deploy it to AKS as well. So the only real difference is because I'm not deploying to Kubernetes, I can't use my Helm chart anymore. So I just have some Helm chart, you know what I meant, bicep files. In this case, you could write ARM or Terraform, whatever you wanted. And it's just going to create the Azure resources. I need a container apps. I need a Cosmos because this is going to use Cosmos and Service Bus rather than Redis and RabbitMQ. Yes, we need a Cosmos database because you always need a Cosmos database. We need a Service Bus. Yes, that's pretty much it. And that's the code changes we need to make. Write those down.
I don't think you have to work on color.
So yeah, the point there being that the only changes we've made are to those deployment things. In this case, creating the resources, and then we've chosen the different components to point to Service Bus instead. Once I then run that, hey presto, I get my eShop now running on app service. You can see all the same containers are there. It's also created the SQL because each service has its own SQL database. This, because we're microservices, baby. But it's the same app, same thing. See the same things. I get the same site. So I was hoping Damien would be here because then he was going to be my antagonistic question. Dapper does a lot more than that, but I guess the bit I wanted to focus on tonight was how it can support moving both between on-prem and cloud, but also moving in different things. Because something running on container apps is going to be a lot lower resting price than something running on AKS, for example. Because when you're deploying on AKS in a real production environment, you're going to have multiple system nodes, you can have worker nodes, you can have all that kind of bit. You might want to move your app for various reasons between AKS and this. You can do that with just using a slightly different deployment file, but no code changes. So you don't need to go and change your code. You don't need to retest your code from a functional code point of view. You obviously need to test your deployment scripts, but the actual app, you're not going to change it. So that's a lot to take in, but it gives you the idea. So let me end up by kind of just simplifying it down. So really what we're talking about here is, as I said, right, we want to, hybrid apps to me really are about being able to easily deploy it where I want to deploy it and being able to use services I want to use. And I want to write the least amount of code to do that, because writing code to talk to Service Bus, it might be necessary, but it doesn't add any business value per se. If I've got another way to do that, and it does all the functionality I want, because obviously you might have some really advanced use cases for Service Bus because it's a super rich platform. But it's the old 80-20 rule, right? Most time people are writing a message to and reading a message off. You can cover that. So we could deploy our app to AKS and have it with Cosmos and Service Bus. We could take it and move it over to container apps to reduce the cost, and maybe we use table storage, super cheap, as our persistent store and Redis over there. Or we might want to pull it back on-prem and use whatever the heck we want, whether that's Azure PaaS services deployed there, it might be in cluster containers, or it might be on-prem resources. That's the dream and that's the vision. And yes, that's pretty much what I had. So, any questions? This is where Damien was going to tease him.
I have one quick question.
Yes.
I imagine you still got a little bit of that lowest common denominator problem. Like, it wouldn't be as bad, but I imagine the features between Rabbit and Q1 Service Bus are different. And Dapper would.
Yeah. So yeah, and that's what I'm saying. So it supports it's the Dapper APIs. So for example, State Store API has a set number of functions.
Yeah.
The actual backing store might do way more than that, right? So you need to evaluate it. But again, I'd say it's the 80-20 thing. If you need it, absolutely use it. The nice thing with Dapper is that you can do that in parallel. So you could use where you need it, write your own thing. Where you don't need it, use the simple thing. But absolutely. I don't know Rabbit and QPML, but I know for service bus, you can do all sorts of super sophisticated things. And if you got that, but yeah, again, particularly the more and more we move to microservices, they're doing simpler and simpler pieces. And yeah, if you need to be able to move them between places and do things, it's super interesting.
You mentioned, people might move Azure Container Apps to AKS for a variety of reasons. I'm interested if you know on the top of your head what some of those reasons might be.
Yeah. No, I've literally got questions. So here's one. So, as I said, like Kubernetes, even using AKS, there's a lot of operational stuff to go through in Kubernetes. So I've got customers where they're deploying, they're moving to a real Kubernetes as a strategic platform, and they're working through it and they're doing super good, and it'll be ready in 18 months. In the meantime, they've got projects that need to go live next month. So there's that. The other reason I've got customers use it's completely different in that, because once you've got it in Kubernetes, one of the other interesting things is how do you charge your internal customers for using your cluster? Because, yes, you can scale, but whether, there's a resting cost and what do you do? CPU, it starts to get kind of interesting. So then they go, oh, well, one approach is to, okay, we'll have a node pool per business unit. And then they get their own build, which is great, but then potentially you've got even more things. So another scenario I've got them is where they have a certain cost they charge their internal customers to be on a internally managed AKS, but they go, or you could do it over here on Container Apps for, a tenth the price. Again, it's not apples for apples. Container Apps does the microservice thing well. It does service things, but it doesn't support Windows. There's scaling limits. So if it's the right tool, it's great. If it's not, then Kubernetes. But it's just nice being able to move the containers between those without worrying about code changes and things.
Can you flick between the eShop microservice and the eShop Dapper?
The architecture one?
Yeah,
Yeah, they're not identical.
I can appreciate that. I just wondering if you could translate for me.
Oh, sure. Hang on. So that's the containers. By the way, both of these are there's a GitHub repo with the code as well as like a full book, an ebook, which is like hundreds and hundreds of pages, which talks you through all of them.
So you've deployed at a microservice level, you've deployed each of those web shopping things in the container, and then there's a further abstraction over.
Yeah.
Next.
You mean here?
Yeah.
Yeah. So they've got the back end for front. So they've got an aggregator, if you like.
And the next bit, taking those, the next slide, could you do a bit of a translation of what's on this slide?
Oh, okay. Hang on. Let me just rearrange this. Maybe I've got to. Can I do this while it's? Hang on, I can jump to it. So this changes. So ignore this. We get down to one app, which is Blazor. Let's jump to this one. This one? Yeah. So this is still here, right? So the aggregator is still there, but what's interesting is not everything uses it. So if it doesn't need to use it, it'll go direct. Say the basket one, for example. The basket gets updated all the time, irrespective, whereas the other ones go through the aggregator to do that. And they will actually talk through a gate. This API gateway, this is in the cluster. This isn't like Azure API management or anything.
Yeah. Because they have the Dapper private solution.
Yeah. But it's a good example to look at because it does talk through Azure. And we've spoken about the components part, which is fitting. But the service invocation secrets management because that's another big one. Like, so, if you're in Azure, you want to use Key Vault. If you're on-prem, you might use something else. You can just abstract that away again. And then it does have a full actors implementation if you want to use that as your kind of approach to data.
I like the bit that you hit the identity service rather than having the back end or front end sort of scenario.
Mm.
But if you've written your Blazor for REST, but then you got adventurous and did a gRPC or something of that nature, I'm just interested. You're saying that you don't have to do any code changes.
So the gRPC in that diagram, it's only talking about the connection between your app and the data sidecar. So in this case, Blazor is still talking HTTPS
right
into the app, but internally, yeah, because remember, your app only talks to its sidecar. That's when you're saying, how do you want to talk to it, gRPC or?
Right, so it's the protocol behind the scenes.
Correct.
Not,
Yep.
So you
No. So your front end doesn't know any better. It's talking HTTP.
Yep. Okay.
And the main reason for using the non-HTTP is just the efficiency of the gRPC. It's a binary kind of format.
Well, that was confusing with the translation.
Yeah, sorry, yeah. And it still throws me when you look at code using Dapper, all the calls that are HTTP 127.0.0.1, which, yeah, my poor brain goes, wait, what? We're in production. But it's talking to the sidecar. You can run Dapper completely standalone, so just on your VM, and it'll just run them as processes. So you don't need Kubernetes or anything like that. But yes, I think I need Damien to do an anti-Dapper presentation so we can have some interesting discussions. I think the biggest challenge I had initially, and I think a lot of people have, is the to your point. But I use this super advanced feature on Service Bus or whatever.
Yeah.
And if that's the case, then that's not going to be the way. But again, that's only for that piece. But I think for a lot of developers going to microservices, they're not doing that much these days.
It feels like a middle ground between like just VMs.
Yeah.
Yeah.
Yeah. But the fact that it does, so it does service. So it's really focused on, because one of the other questions I get is, what's the difference between this and like a service mesh? And to me, the difference, Dapper is, it's about developer problems, Dapper, whereas the service mesh is more a networking level. Here's how you go and resolve these things. And so there is an overlap, and you can use service mesh with it, service meshes. But most of this stuff here is really developer problems. How do I call a microservice? How do I do this? How do I do that? And we haven't touched on tonight, but like it has all sorts of cool things baked in with observability. So you can say, yeah, use Zipkin, use App Insights, use whatever, and then all of a sudden everything's wired up and see what's wrong. So there you go. That's my 15-minute presentation.
There you go.
I went a little over, but that's okay.
Thanks very much, Todd. As usual, that's phenomenal presentation.
She was a little rough, but that's it.
Yeah, that's awesome. And as everybody knows, we always appreciate our speakers.
And we appreciate what you give the speakers.
Fantastic. All right. So, yeah, we do have a meeting scheduled, I guess, probably the 11th of January, I think it is, Wednesday. And yeah, I hope to see you all back in the new year. I hope everybody has a safe and relaxing holiday. And the only thing I'll ask is, if you brought a bottle in, just bring the bottles out to
The recycling bins.
Yes.
This way now.
That's fine. But yeah, thanks everybody for coming.
Thank you. Yeah.
Thank you.
It's from the back, yeah. So it's
Yeah,
brother.
Todd, which of those ones that were in the